If you recall, we ended the previous video talking about the difficulty in visualizing flows in the field or in the lab. And we talked a little bit about how we can add tracers to the flow in order to help us see where the flow might be going. And so to give you an example of that, if there's a fan in this room on this side and it's blowing across this way, unless you have some sort of tracer like my hair flapping, you have no concept that there would even be any fluid motion around me due to the fan. And so if we looked at a point here, you wouldn't be able to visualize that. And so what we might do is introduce a little bit of smoke that'll go by, and you'll be able to see where that flow is going. You've probably seen examples of this in car commercials when they put a car in an aerodynamic tunnel and you see the little lines of smoke that go along. And we'll talk a little bit about that in this video. Okay, so there are several ways that we visualize flows, and one of the most useful is what are called streamlines. And these are lines that are everywhere tangent or parallel to the velocity vector field. I'm going to give you an example of what that looks like. Consider the oblong shape we have below. It can be a bridge pier or some other object in a flow. And let's assume that we have some flow coming in from left to right on the screen like this. And if we follow along one velocity vector, so if we start right here and we follow this velocity vector, it's going to, as it approaches the cylinder, it's going to divert something like that and come back. And then what we can do is you connect those dots with a line that's always parallel to those velocity vectors, and that will define a streamline. So let's do that. So now we're going to do our best to trace this back out. So it's going to look something like this. And so that defines a streamline. And we'd see a similar line on the other side of the object. So it's going to do something like this. And then further out, the flow is going to be deflected a little bit less on both sides. And then finally, the object itself, the surface of the object itself, no flow can pass through that object, which means that any flow that's near that surface is going to be tangent or parallel to the flow direction itself. So that the boundary of that object defines a streamline. And so there's another streamline that arises because of that, and that's coming straight out of the middle of both sides. Okay, so that defines a streamline, and now we can really see what the flow is doing around this object. Okay, the velocity on that streamline can change in space. However, the streamlines themselves do not change in time often. And when they don't, we call that a steady flow. So if the pattern of the streamlines does not change in time, then the flow is called steady. And what that means in our mathematical term is that dv tilde over dt is equal to 0. Okay? So although if we have a flow field with some streamlines, the velocity can change in space, it means the velocity is not changing in time at any particular point. And that's what we call a steady flow. And you'll hear me use that term quite often in this class. And if you go on to take other fluid classes, we'll talk a lot about steady flows. In fact, for most fluid analyses, what we often do is start with a steady flow case and then take the next step to an unsteady flow case to see what happens. You just heard me mention unsteady, and you might guess that that's where the pattern of the streamlines does change in time. And so in that definition, we have dv tilde over dt is not equal to 0. And a really good example of that is if you have a cylinder, something like this, and you have a flow coming from left to right at the cylinder, and at intermediate flow speeds, you'll see the wake vortices start to develop in an alternating sense behind it in the wake. Okay, and so even though on the left-hand side the flow coming in might be steady because of the generation of these vortices, if you're sitting at a point here in the flow and you're just looking at that flow at that point, the velocity is going to change in time, and so the streamlines are going to change in time. And that's what we call an unsteady flow. Okay, there's two other ways we visualize flows, but those are more aligned with what we do in the laboratory in the field. Streamlines we use graphically more often than not to visualize like we did in the previous example when we're looking at a piece of paper. But in the lab or the field, we often introduce what we talked about earlier, flow tracers. In flow tracers, there's two types. First, flow tracers can generate what are called path lines. And path lines are a locus of points that a particle passes through. So let me draw that graphically for you. So that looks like this. If we have a particle here at t equal to 0, and we follow that particle and it goes here, and at t1 it's here, and then at t2 it's here, and t3 it's here, and so on. And we connect all those dots together. That's a path line. It's the path that the particle followed in the flow. Okay? Another way we can visualize flow is called a streak line. And streak lines are slightly different. They are the locus of points all passing through a point. And you've seen examples of this too. So if we consider, say, a smokestack, and there's some smoke coming out of it, like this, then all these particles define a streak line, because all of those particles have at some point passed through this point here as they come out of the smokestack. And so we have a streak line there. Okay? So we have streamlines, streak lines, and path lines. And we talked about what streamlines do in unsteady and steady flows. What's unique about steady flows, and where path lines and streak lines really become useful for us when we're looking at doing fluid analyses, is that for steady flow, streamlines are the same as path lines are the same as streak lines. Okay? So, and so if we have a steady flow, these things are extremely useful in visualizing the flow and interpreting what the flow is doing around an object or in its environment. Okay? That's it for this video. We'll move on and talk a little bit more about flow rates in the next video.